Hello everyone, today we are going to look at how to calculate the mean trajectory of a particular stochastic function. In order to do that, first of all we are going to create a stochastic function. Say it is a random walk. Each random walk consists of t steps, and these are the possible move for the particular random walker. That is, he can move either two steps towards right or one step towards the left. And so we are taking the sample of this particular values. That is, we are taking the sample from this S, and we have t steps, so we are doing sampling over t times, and we are using the replace function as true since we want to repeatedly take the values from the 2 or minus 1. So we'll show that, and t is equal to 10. That means our random walk consists of t steps or 10 steps. You can see that the sampling was taken like this, and either minus 1 or 2 is selected randomly from this particular type of system. And we want the cumulative sum in order to find the actual displacement from the original position. So the particular function is cum sum of r. You can see how it varies over time. So this is the actual displacement of the particular random walker over time. And so we are more interested in the cumulative sum of the particular random walk than the sampling values. So we are returning the cumulative sum of that particular random walk. We can also plot that. It is cumulative sum random walk over 100 steps. It will look like this. So that's it. This is our random walk or the stochastic function, and we are going to find the mean trajectory. That is, if I am averaging over 100 times, how will the mean trajectory look like for this particular stochastic process? Just executing this again, and just okay. So in order to find the mean trajectory, I am initializing the values n and t. N means the number of times I am taking the average of. That is, I am taking the random walk with t steps up to n times. So n times I am iterating and finding the mean value of the random walk at each time. I am making two lists, L and ME, and first of all what I am doing is appending all the values of each random walk into a single vector. I'll show that. Say my initial I am repeating it for 5 times, and each time step, each random walk consists of 10 steps. So this is what my effective random walk or the vector L looks like. The first 10th element belongs to the first random walk, the next 10 element belongs to the second random walk, and the last 10 elements belongs to the final random walk. So what I want is, I want to convert this particular vector L into a matrix with rows and columns as t and n. That is the number of steps for each random walk as well as number of times I am iterating. So I am converting it into a matrix. Let's look at that matrix. So this is our matrix. Here you can see at this is the first random walk, this is the second random walk, this is the third random walk, and this is the 10th random walk. For an easy visualization, let's transpose this into a matrix. I'll show that. So here we can see that this is the first random walk, this is the second. So each row corresponding to a random walk and each column corresponding to the each iteration. So this is the final random walk. Now I want to take the average over each column. So the average over the first column gives the mean value at the first instant. Average over the second column gives the mean value at the second instant, and average over the last column gives the mean value at the final instant. So I am going to average this particular matrix column wise, and in order to average I want to find the number of rows it have. We already know that it is n, or you can do it by finding the dimension of this matrix, that is dimension of A, and the second element is actually the number of columns. So finding the mean value of all the columns, and you know that for a matrix A, bracket of comma I will give you each value of these columns, and we are going to find the average over. So the mean is actually calculated and appending to the ME list. So for all rows we are calculating the, for all columns we are calculating the average value. I am calculating the average value. Now I want to plot it. So the maximum value of the x-axis is actually t, and the y-axis minimum value is minimum value of matrix, as well as the maximum value is the maximum value of the matrix, and the x-axis is actually time, and y-axis is the displacement, and the heading I am giving it as mean trajectory of random walk. Now I just want to plot all the all the trajectories in gray and the mean trajectory in red. So for that the command is for all the value particular set of, that is for all the rows. I'm calculating it for all rows. For all rows the line should be such that it should be gray, and for the mean trajectory it should be red. So this is all about our program. Now I want to execute it. So my mean trajectory, now I am going to find a random walk consisting of 100 steps, and I am iterating the particular random walk over 100 times. So this is what it looks like. So this is the mean trajectory of the random walk which with 100 steps which I iterated over 100 times. So the red line corresponding to the mean value, and each of the gray line corresponds to the each iteration values. You can see the values are almost linear, that is with minimal amount of fluctuation as the number of iterations increase up to 100. So that's all about mean trajectory of a particular stochastic function. You can do the same with another function. Say if my random walk was one step right and one step left, it will look like this. So the average value will be 0, since plus 1 and minus 1 cancels each other. So in long run the average value will converge to 0. So that's the property of a random walk with equal left and right, or equal and opposite values at the particular distance steps. So for any trajectories, any stochastic trajectories with t steps, for iterating it over n times, you can use this particular function. Okay, and this is a simple function in order to find the mean trajectory of any stochastic processes.